push that rock here with Simpson math. Let's graph the reciprocals of the sinusoidal waves. Okay, so the sinusoidal waves are sine, here's the sine right here, and cosine, and we want to graph the reciprocals. But before we do that, we want to think about what happens to numbers as to their reciprocals as the numbers themselves approach 1, and this little subscript, a negative here, means in this case from the left. So in other words, if we get close to 1 from below, so like 1/2 is not that close to 1, but if I reciprocate it, I get 2. Well, what if I get closer to 1? Okay, if I get closer to 1 from below, you know, getting close, smaller numbers smaller than 1, getting closer to 1. So 3/4. 3/4 is closer to 1. What happens to its reciprocal? Well, it becomes 4/3. You know, that's 1.3, and the 3 goes on forever. Okay. Okay, let's get even closer, like 9/10. What happens there? Oh, well, I get 10/9, and that is 1.1, and the 1 repeats forever. Okay, so notice I'm still getting close to 1. So this side's getting close to 1, the reciprocal's getting close to 1. So I was at 2, now I'm at 1.1, much closer to 1. Well, what if I did 99 hundredths? Well, that'd be 100 over 99, which is 1. 99 goes into 100 once, and 199. So I got even closer to 1. So what we're learning is that as x approaches 1 from below, then this, the reciprocal, approaches 1 from above. That's what that superscript plus means. Now, let's think about getting close to 0. And it doesn't matter about the direction this time. I'm going to come from the positive direction. So I'm going to diminish to 0. So like I have 1, the reciprocal is 1. I have 1/2, so I'm going down to 0. The reciprocal is 2. I have 1/4, so I'm trying to get to 0. Our reciprocate is 4. But you see that if I had a -1 here, then there would just be negative. If I had a -1/2, it'd just be -2. If I had a -1/4, it'd just be -4. So kind of the same thing's happening, only instead of getting bigger, it would be getting bigger in the negative direction. In other words, actually smaller, technically, because -4 is smaller than -1. But anyway, let's just keep going. So if I did 1/10, it would be 10. And if I did 1/100th, it would be 100. So we see that as x goes to 0, then 1 over x will be going to infinity. Now, if x is going to 0 on the negative side, then it would be negative infinity. But it's going out to infinity, far, far away from 0. Okay, so with that knowledge in hand, it's very easy to graph the reciprocal of the sinusoidal waves. So one of the reciprocals is cosecant. That's the reciprocal of sine. Okay, so this is equal to the 1 over sine of x. It is not equal to sine raised to -1. That notation refers to a completely different thing, an inverse, which is not the same thing as a reciprocal. I know in grade school your teachers frequently said inverse and reciprocal synonymously, but they didn't mean to. They were just kind of they were shortening the phrase multiplicative inverse. A multiplicative inverse and a reciprocal are the same thing. But an inverse and a reciprocal are not the same thing. Okay, so we really should keep those two words as separate. So this is the reciprocal of sine, and the shorthand for it is, or the name for it is cosecant of x. So I'm going to first draw a sine wave. So in blue, I'll draw a sine wave. Okay, well, we know what sine looks like by now. You've been practicing it, and you've gotten very good at it. If you're not one of my students and you're watching this video, you really need to be really good at graphing sinusoidal waves, sine and cosine, before you try to graph their reciprocals. So here is the sine wave. Let's label our axes. So sine goes from -1 to 1, so this must be 1 and this must be -1. And the peaks happen at pi halves. So this must be pi halves, pi, 3 pi halves, and 2 pi. And there you see a complete cycle of the sine wave over one period. So now what I want to do is graph the cosecant wave, and I'll do it in black. Now, we just said that as you go towards zero, as these inputs go towards zero, as these outputs are going towards zero, these y values are getting closer and closer to zero, see? As the y values go closer and closer to zero, the reciprocal of those y values will go to infinity. So these points really close to zero, their reciprocal values will be very high. So I'm going to put an asymptote here, because that's going to create asymptotic behavior at these roots. So at every root of sine, there will be an asymptote. Okay. Then as the outputs get close to 1, I know that I'm getting the reciprocal outputs will be also outputs getting close to 1. So as we go backwards here and these y values go up to 1, well, these y values will be going down to 1 because they're the reciprocal of these values. So you see that this information gives us everything we really need to know. There is a point where sine is a half, right? When at pi 6 sine is a half, well, cosecant will be the reciprocal, that will be 2. Okay, so there will be another point over here at 11 pi over 6 where, let's see, 11 pi over 6, that sine will be a half. I don't mean 11 pi over 6. I mean 5 pi over 6, because this will be 6/6 stuff. 11 pi over 6 will be over here, it will be a negative half. Okay. So anyway, 5 pi over 6, sine will be a half, so cosecant will be 2. But then as the y values get close to 0, it's taking off. So the cosecant has this U shape. It's not a parabola shape because parabolas don't have asymptotes, but it is a U shape, okay? And then on this side, the only difference is, well, all the y values are negative. Well, the reciprocals are also negative, so it's just a negative, it's just a reflection of that one. And there is one cycle of the cosecant graph. One cycle, its period is 2 pi, just like sine's period. And there you have it. Math made simple. Simpson Brand.